Adsorption plays an important role in all phenomena and processes where surface properties are essential. The phenomenon of adsorption finds very extensive applications in industry, research laboratories, and in everyday life. Some important applications of adsorption are production of high vacuum, gas masks, humidity control, clarification of sugar, chromatographic analysis, heterogeneous catalysis, adsorption indicators, separation of inert gases, froth flotation processes, and curing diseases. Let us discuss these applications one by one. We will first discuss production of high vacuum. A vessel that has already been evacuated by a vacuum pump may still contain traces of air. If a bulb of activated charcoal is connected to this vessel, the remaining traces of air get absorbed by the activated charcoal. This results in the production of a very high vacuum. Gas masks, used by miners in mines, provide protection from both particulate matter and poisonous gases. These are based on the phenomenon of adsorption. Gas masks contain activated charcoal or a mixture of adsorbents that preferentially absorb large volumes of poisonous gases and thereby purify the air for breathing. Another application of adsorption is to control humidity in the air. Silica and aluminium gel are used to keep the relative humidity as low as possible. They absorb moisture from the air, thereby preventing damage to electronic devices and musical instruments. Silica gel is also used as a means of preservation to control relative humidity in museums and libraries and exhibitions. An application of adsorption from solutions is the clarification of sugar. Animal charcoal is used to decolorize sugar solution since it absorbs the coloring materials and carries them with it when separated from the solution, leaving behind a clear solution. The phenomenon of adsorption has provided chemists an excellent technique of separating various components of a mixture. This technique, known as chromatographic analysis, is used widely in analytical and industrial fields. Chromatographic analysis is based on the selective adsorption of certain substances from a solution by a particular solid adsorbent. Let us now discuss heterogeneous catalysis. Adsorption plays a very important part in the catalysis of gaseous reactions by solid surfaces. Let us see how heterogeneous catalysis works. According to the adsorption theory, gaseous reactants are absorbed on the surface of a solid catalyst. This increases the concentration of the reactant on the surface of the solid catalyst, thereby increasing the rate of reaction. The theory also explains the greater efficiency of the catalyst in a finely divided state. A majority of heterogeneous catalysts are solids. For example, Iron is used as a catalyst in the manufacture of ammonia. The use of vanadium pentoxide in the manufacture of sulfuric acid by the contact process and of finely divided nickel in the hydrogenation of oils to fats are other excellent examples of heterogeneous catalysis. An important application of adsorption in the laboratory is an adsorption indicator. An adsorption indicator is a substance that is adsorbed along with a change in the color at or near the equivalence point of a titration. This finds use in precipitation titrations. For example, potassium bromide is easily titrated with silver nitrate using eosin as an indicator. Fluorescein is another dye that is used as an adsorption indicator. The phenomenon of adsorption is also used to separate inert gases. A mixture of inert gases like neon, helium, and argon gets separated because of the varying degrees of adsorption of the individual gases on coconut charcoal at different temperatures. The amount of adsorption of noble gases increases with an increase in the atomic mass and a decrease in the temperature. The froth flotation process of concentration of sulfide ores in metallurgy is also an adsorption phenomenon. The ore particles are adsorbed on the surface of the froth, while the gangue settles at the bottom of the tank. Adsorption plays a very important role in biological systems. One very important application of adsorption is in curing diseases. A number of drugs get adsorbed on the surface of germs in the human body. The germs are killed by the action of the drug and the disease is eliminated.